Hello, welcome to How Farmers Fridge Scaled its Microservices with Epsagon's Observability solution. When you joined today's webinar, you selected to join either by phone call or by computer audio. If for any reason you would like to change your selection, you can do so by accessing your audio pane in your control panel. Also from this control panel, you'll have the opportunity to submit questions to today's presenters by typing your questions in the questions pane. We'll collect these and address them during the Q&A session at the end of today's presentation. If we're not able to get to your question, we plan on responding to each of you personally through email. The recording of the webinar will be available 2 to 3 days after the conclusion of the presentation, so watch for that email. My name is Ryan Vandorf. I'm a Partner Solutions Architect with Amazon Web Services, and I'll be your host and moderator for the webinar today. Little housekeeping here. I want to introduce our speakers real quick. We're going to do that, and then we're going to talk about the Farmer's Fridge case study by Ben Bernays. And then Ron Riebensaft from Epsagon is going to talk about observability and modern applications. And I'll follow up with some of the general services that we offer to enable these kinds of activities on AWS. And then we'll follow up with some Q&A and leave you with some next steps to take. So let's introduce our speakers today. We've got Ben Bernays, engineer from Farmer's Fridge. We've got Ron Riebensaft, CTO and co-founder from Epsagon. Hi guys. And myself, Partner Solutions Architect from Amazon Web Services. All right, I'm going to hand it over to Ben. He's going to talk about how Farmer's Fridge has a really cool, unique solution with these healthy food vending machines and how they use that.
Hi, I'm Ben Bernays. I'm with Farmer's Fridge. So a little bit about Farmer's Fridge and what we do. Farmer's Fridge is on a mission to make it simple for everyone to eat well. We do that through owning and distributing a fleet of automated smart vending machines that serve fresh and healthy food. We have 400 of these fridges across the Midwest and East Coast. They're located in airports, hospitals, college campuses, and more. Recently, we also started a direct-to-consumer home delivery program. That delivery program was made from scratch, and in less than 2 weeks, we had a viable business, and we were able to retain our full staff, both at the facility and corporate levels. So how do we do this internally? Well, it starts off at our 50,000 square foot facility in Chicago, where we make and package all of our food. We do that by sourcing local food wherever possible, working with partners who share our values, and by doing as much of it by hand as possible. We then send it out to our machines via our dedicated team of drivers. They then stock all of the food and remove any unsold food, which is then donated to local community members. So a little bit about our technology stack. One, on our smart fridge side, we run a complete custom software stack where it controls all of the item dispensing, monitoring, controlling the temperature, verifying the shelf life prior to vending, and also powering our 32-inch touchscreen, which is how the customer interacts with our machine. All of this is powered by AWS IoT over-the-air updates in order to make sure it's running the latest versions. On the cloud side, we have a platform to monitor and control each of those fridges. We use AWS AppSync for API and real-time communication. We use Lambda functions for compute needs, DynamoDB for storage, SQS, SNS, and Kinesis for messaging, as well as CloudWatch logs and metrics.
Great.
So here is a high-level architecture diagram. You can see that there's many different managed services, and in there we have none. We don't actually manage any of our own EC2 instances or other servers. So we run a fully serverless environment. This has many great pros, but it also makes it very difficult to track errors across services, there's no centralized location for triaging any errors, and it makes it very difficult to understand what resources were interacting with what and how they were impacting each other. So I think that this is where we went out and found Epsagon, which was able to really help us provide a single place for our engineers to troubleshoot and alert our serverless environment. After implementing Epsagon, we reduced our mean time, or improved our mean time to resolution by 55%, as well as reduce our number of unalerted or silent incidents by 50%. This really allowed us to greatly increase our development velocity because a lot more people had greater confidence in our solutions. So now I want to talk about a real world problem where we actually implemented Epsagon. So our data warehouse pipeline is a set of DynamoDB tables, streams, and Lambda functions, all aggregating the data in a single AWS Aurora database. So that's spread out over multiple regions in public and private subnets, and a lot of it is done in an asynchronous and batch process. So to monitor the Lambda functions, we added the Epsagon tracing library, which allowed us to automatically send data to Epsagon with virtually no changes. For cross-region events, we relied on Epsagon's ingestion endpoints in each region to provide low latency ingestion and aggregation of that data. For public and private subnets, we had to work with them in order to prioritize their implementation of private link, which allowed us to send data completely on private internet within our VPC back to their platform. At the end, we were left with a great system that we can now visualize in its entirety across multiple regions. We can see that all 15 or so DynamoDB tables, how the data is streaming via various Lambda functions across another Kinesis stream, and finally into the last Lambda function, which actually writes it into Aurora. So prior to this would have taken hours of debugging, looking through many different CloudWatch logs and understanding what was going in and out of each table and where in the stream each Lambda function was. So as a result, we got a unified debugging tool for all of our metrics, logs, and included a cross-region view. We got automatic ingestion and alerting of exceptions via CloudWatch logs, which meant that as we add more Lambda functions, Epsagon is always alerting us automatically by subscribing to those streams. And lastly, we also got a visual representation of individual invocations as well as on the application level, which makes onboarding new engineers much easier because a graphical representation is much easier for them to understand than a text-based one. So now I think I'm going to hand it over to Ron to talk about observability in modern applications.
Yeah, thanks, Ben. Thanks for the kind words. And I think your use case is one of the greatest examples how to move fast using serverless and don't compromise engineering, don't compromise downtimes, and still move super fast. And by the way, I tested Farmer's Fridge on one of the fridges in Chicago. Super tasty, like a great alternative to anything that there is on the airport. So a great product, super great product.
Thank you.
In the following part, I'm going to speak about observability in modern applications, taking what Ben talked about and drilling down to what's important when we're doing digital business and e-commerce and retails and things like that. So starting first with understanding a little bit more about what we're looking for today when we're doing when we're looking at the digital experience or customer experience in our website. We have 4 golden signals or 4 vital signs that tells us how good do we have our service and how good is our customer experience. Starting with latency, which is super important for customer to have a very fast response times, very fast duration for every operation that he's doing. So that's one thing we measure. Second comes the amount of traffic. This is important for us to understand how much customers are we serving, or whether there is a upscale or downscale in the amount that we're serving. Also, errors are super important because we tend to try to zero them down, but it's important to understand what errors our customers experiencing and which customers are experiencing them. And ultimately, something that's tending to be missed out is saturation, or in other words, how full is our service? Because all three can be good, but if saturation can reach all of a sudden 100%, it means that we can't serve any more customers. So this is another great vital sign that we need to look at. Once we're looking on them, we need to make sure still that we're delivering the best experience out there. And to do so, we have some new challenges that are being introduced to the teams like Farmers Fridge or any other team that is taking a leap and moving towards modern applications. One of them, and I think Ben really emphasized it, involves around troubleshooting. When a customer is having a bad experience on our website, which can happen, and our website is not composed with just a single component, but composed with different resources, different parts, different services that are all communicating with one another, as we can see on the right-hand side. It makes troubleshooting time much longer, much more complex, which will spend your engineering time ultimately. Second, we need to observe, understand how our system reacts, what our system composed with. When a new engineer onboards, he needs to understand how he interacts with the rest of the system and the rest of the services. So this is a good kind of place to observe actually what's going on. And ultimately, we need to optimize our applications. We need to understand what's our current performance and how do we make it better, and where do we need to improve our performance. With all of that, a great term that comes in called observability nowadays. Observability tells us, in other words, how can we understand our system in production, or how can we understand what's going on in our applications. And to do so, we have three main metrics, or three main pillars. The first one is metrics, which are aggregatable, and we can look at it as number of requests or traffic or saturation and everything that we saw before. Second comes the logging, when we need to roll our sleeves and start debug something bad that happens. We need to look at some raw information, some debug data, some logging, which will help us. And ultimately, we need tracing, because that helps us glue everything together and also helps us understand complex scenarios and complex systems that are not just single kind of monolithic application. Sorry. And the main problem with today is that you're having a different tool for each and every aspect or each and every pillar, which is not quite good for engineering teams, because then comes blaming one another on, we saw something on the metrics, but where is it on the logging, and who is responsible for tracing? Having all under the same tool really helps the productivity, or in other words, kills the separation productivity that needs to be handled. Just as some examples from Epsagon that are relevant for retail and e-commerce and other scenarios like that, Epsagon provides this kind of observability, which is completely automated, no setup needed, no maintenance, no training whatsoever, which comes great for teams that just want to leap forward and work on their main business, deliver what they need to do best. It supports any modern environment that exists on AWS, like serverless, Lambda functions, AppSync, Fargate, Kubernetes, ECS, and so on. It connects every request in every scenario between each and every service. It helps you search and analyze your data, like understand customer journeys or understand errors, and it helps you ultimately to pinpoint problems and solve them as quickly as possible. On top of that, Epsagon provides some very unique capabilities specifically for retail applications. Things like understanding a specific customer experience in our website. So as you can see in this example, I'm filtering a specific customer customer email over my existing labels to understand his specific journey over my website, to understand how many errors is he experiencing, or what's the average latency that he's having, and even drill down into a specific event, which will help me ultimately to pinpoint down and understand what exactly he had on his experience, or on his website, or on his trace or transaction. In this case, it helps me to understand all of the information under a single pane of glass, where I can see the exceptions, I can see the details, I can see all the involved resources, and this comes out of the box, so your engineers don't need to train for that or manually set up everything to get that out of the box. Epsagon also provides alerting to all kind of integrations today, like Slack, Teams, PagerDuty, VictorOps, OpsGenie, and so on. So everything comes out of the box ready for you to help your engineers push forward and deliver faster. And with that, I would love to hand it over to Ryan.
Thanks, Ron. That was very insightful. I wanted to call out some of these services that AWS helps provide. Obviously, there's some IoT jobs, SNS, Kinesis, but I just want to call out a couple that are really central to the tenets that Epsagon helps solve. And AWS has some services to help end users solve that as well. Let's talk about that. So really, when you're running an application on Amazon Web Services, really the question comes to be is how do I monitor and debug my serverless application? You can see in a serverless environment, like what Ron and Ben showed you, it's really chaotic, and there's a lot of different things running all in parallel. You need something to stitch those together. You need some kind of tracing ID on a cohesive transaction, because every interaction may be going through a different server running somewhere else. Or serverless function running somewhere else, and you don't want your developers to have to piece all of that together if they need to troubleshoot something that's going on. So you'd rather spend your time doing business application development and making new features for your product instead of trying to spend time troubleshooting all of these. And that's what makes these kinds of tooling worth its weight in gold. So you've got all of these things going on, and how do we bring them together? AWS has a couple tools to help with that. One of the central ones is called Amazon CloudWatch, and so all the logs go in all your serverless applications in a CloudWatch, but you can also monitor metrics, set alarms if certain things are going on. You can have a dashboard set up to get some more observability, and then have agents even running if you're doing not serverless types of things where you need to monitor what's going on remote servers. And then another service that we have is called AWS X-Ray. And really this is providing a trace or an end-to-end view of your application. So you can instrument your code with X-Ray APIs and get that a single tag across a whole transaction, no matter where it's going, and get some sort of visibility to what's going on. And how AWS X-Ray works, really it just helps you analyze your application and your microservices and serverless, which makes extremely difficult stitching these together. So what it does is it collects traces from each of the underlying applications, it records those traces into X-Ray, and then lets it view you in an interactive service map. And then you can see the statuses for each service going on there. And then from there, you can analyze the issues that are going on. So everyone has access that's running AWS services to be able to enable these and run and see what's going on with your service. I wanted to highlight another service that we have that Ben at Farmers Fridge they're using is AWS AppSync. And so this allows you to have an easy way with a GraphQL interface to have an API amongst many different data stores. And another problem that it solves with that is distributing data across all these remote devices. So they have all of these vending machines spread out everywhere, and you need to keep the data stores in sync somehow very easily. And AWS AppSync will do all of that heavy lifting for you, so you don't have to worry about doing that yourself. And we support different data sources. We've got ability to do self-documenting APIs. We have a React, Android, iOS, WebJS, Apollo GraphQL client, and right through mutations with an optimistic API. So this is a pretty powerful tool to enable this kind of situation where you've got data spread out all over places and you need to keep it synchronized and need an API to be able to get to that data. All right, so some people have sent in some questions via the question bar. So let's go ahead and take a look at what we've got here. So I see one come in here. We've got a question from a user. Let's see. When would you recommend choosing a monitoring solution, and why not in-house? I think Ron would be a good person to answer this one. What do you think?
Yeah, I would love to take this one. So when you should choose a monitoring solution, I would say as soon as possible. Mainly, it's like tests or anything else that you're doing when you're starting a project. The earlier that you'll do that, the more prepared you'll come for production. Some people tend to think that until you're not in production, don't pick a tool because, I don't know, it might make sense, but I say the earlier that you're doing it, the better and more prepared that you're coming. Now, between in-house and having a managed solution, it might be the same debate for taking a managed solution in AWS versus implementing it on your own. It really depends how much effort you want to invest on infrastructure and developing your own service instead of taking off-the-shelf service that is ready, managed, supervised for you, and everything comes out of the box, rather than implementing it. For most of the scenarios that I've seen, taking a managed solution really fits. That's the whole agenda of serverless and the ecosystem of the services. Only at a certain scale, really, really high scales, hundreds of billions of events or something that's really large, and especially when you're having very large engineering teams, you might consider doing it in-house. But other than that, I would really recommend at least start with a managed solution, understand what it can bring, and then potentially implement it on your own if you think that's easy.
Yeah, I would agree. I mean, why focus on undifferentiated heavy lifting of trying to stitch all this together yourself when people have solved this problem already and have a proven track record? Going with that seems to make a lot of sense. So you can really focus on your product and not doing all of that. All right, I think we've got another one come in here. All right, somebody's asked, how did you decide to use AppSync? Maybe Ben be a good person to answer this?
Yeah, so when we were rethinking our API solution or our implementation, we were originally going to use API Gateway, but then in the end, we decided on AppSync because of all the real-time data aspects of it. It allows us to be able to communicate via WebSockets across multiple clients in a fan-out way. It also allows the clients to request exactly what they want, and it provides a singular interface between a lot of different back-end data sources without any of the clients actually having to understand where the data is coming from.
Great.
So overall, we decided that the managed AppSync was really the way to go because it allows us to scale and not think about any of that kind of implementation.
Very good. Very valid point there. All right, I see another one come in here. What are some benefits that you have seen from using serverless? What are some benefits you've seen from being event-driven? It's kind of a two-part question. Ben, maybe you'd be a good person to answer this.
Yeah, so I think, as I said earlier, it's really allowed us to focus purely on our business. I mean, for us, it doesn't matter the rate at which things are happening because Lambda is just able to scale all the way up to whatever level we hit. It also scales right back down to zero. So a lot of our data is really flows based on customer interactions. So as that scales, I mean, we see 10 to 20x spikes throughout the day. And so we scale with that and then scale back down to zero. And so most of the night, we're paying for literally nothing on our platform.
Right.
And
why pay for care and feeding of individual servers, right? When
exactly.
you can have none.
Actually, I would love to chime in and elaborate on the ownership.
Definitely, Ron.
Definitely cost and scale out of the box, it's really great. But for us, we do have some, like maybe 1% or a few percent that are still ECS and not completely serverless by the agenda of serverless. And we see the difference in the maintenance and the management overhead and the operations overhead between our hundreds of Lambda functions and our few ECS clusters. That's dramatic. We can spend days on configuring load balancers and handling the scales of ECS, although it's relatively managed, but not as managed as Lambda functions. And it just this total cost ownership really really, for us, kicks in to shift everything as we can towards serverless.
Right, and that's really key. So some people would say, well, but you have this giant mess of I can't see what's going on. It's in all these places. But with a solution like Epsagon and AWS X-Ray and things like that, that kind of nullifies that argument that you're not losing anything by going serverless, and you're only gaining financially, as well as having a good picture anyway, which is good practice to do, right?
Yeah.
All right.
And to be fair, there is a limit at which serverless doesn't make sense anymore. There is a
Sure.
upper end where you're just using so much, like Ron had talked about when it came to implementing your own solution for monitoring. There's a point at which we're very aware that we'll probably have to get off Lambda because it won't make sense anymore.
Sure, and that may be a financial reason as well. Great. Well, thanks everybody for tuning in to the broadcast. Make sure you check your feedback email and give us feedback for how you like the presentation. And again, look out for that email coming in a few days with any updates to the broadcast, and then we'll try to answer questions that you've submitted that we weren't able to get to today via email. Thank you. I just want to call out some next steps here so you can learn more information about what we talked about today. We've got a link to AWS Lambda, aws to amazon.com/Lambda. You learn a lot about serverless and what AWS can offer there. AWS X-Ray to help you do that observability in applications at aws to amazon.com/X-Ray. You can learn more about AWS AppSync and all the benefits it provides at aws.amazon.com/AppSync. And you can also learn more about our partner Epsagon and what they offer as far as observability solutions like you've heard about today at epsagon.com. And as always, you can try AWS for free at aws.amazon.com/free. Thank you, Ron, and thank you, Ben, for a wonderful conversation today. And we look forward to hearing from you soon.
Thank you very much, Ryan. Thank you, everyone.